Welcome back, everyone. Okay, so let's take a look at this here relationship that we have this data table for. So on our left-hand column, we have the day of the month. On the right-hand column, we have the number of SEPTA routes detoured on that day. So is this a functional relationship? Yes, it is, right? It has an input, which is the day of the month. It has an output, which is the number of routes that are detoured that day. So let's remember what a function is, right? A function is a relationship, right? A relationship that relates inputs to outputs. Specifically, a function takes in an input and it produces an output. Produces an output related to that input or caused by that input. So what's the case? Is it the case that the number of routes detoured on SEPTA determines the day of the month? Or is it the case that the day of the month determines how many routes on SEPTA are detoured that day? Obviously, it's the case that the day of the month is the input and the number of routes detoured is the output. So for this function, an input of 1 produces an output of 3, right? An input of 2 produces an output of 5. An input of 3 produces an output of 2. An input of 4, oh my goodness, produces an output of 0. That's wishful thinking. And an input of 5 produces an output of 28. Well, that's more like it, right? That's more of a normal number. Okay, so we know how functions work, right? And we can just remind ourselves quickly what would be the domain of this function. Well, the domain would be 1, 2, 3, 4, and 5. What would the range of this function be? The range would be 0, 2, 3, 5, and 28. Right? The range is the set of all the possible outputs. The domain is the set of all the possible inputs. So now that we have that to work off of, let's introduce some new notation. Everyone loves notation, so let's introduce some notation. Function notation. Function notation. We have a certain notation specifically to refer to functions, and it looks like this. F of x. This means, well, it's pronounced just the way I said. This is pronounced f of x, and this means a function f is a function of x. Okay, so this is where x is the input, and you get an output, the output associated with that value of x as a result. So you have f, which stands for the function. You plug in the values of your input, right? And what you will get is the associated output. Okay, let's use this notation to look at the information we have here, right? So let's look at our first data point. Whoops. Let's look at our first data point. Slight technical difficulties right now. Let's look at our first data point here, okay? The input 1 produces the output 3 for this function. So for this function f of 1 equals 3. Okay? What about f of 2? What does the input 2 produce in this function? It produces the output 5. So we say f of 2 equals 5. What about f of 3? That produces 2. Okay? What if we wanted to know this? What if we wanted to know what value x satisfies this condition? Satisfies this condition, f of x equals 0. Okay, well, that's like saying what input of this function produces the output 0. And we can see that according to this data point right here, the input 4 produces the output of 0. So therefore, f of 4 equals 0, or in this case, to solve this condition, x would equal x would equal 4. So this here is the notation we're mostly going to be using to refer to functions from now on. This means that there is a function f and it is a function of x. And we normally refer to this notation in words as f of x. You'll often see different letters used. It doesn't just have to be f. Probably the three most common letters used, you'll have f of x, you can have h of x, and you can have g of x. These are just three of the most common letters that are used. You can use any letter you want. You can have a function I of x. You can have a function q of x if you want. It's just your choice for what variable or what letter you want to use in your notation. But the most popular ones you're going to see, probably definitely the most popular one is f of x. The second most popular one is going to be g of x. And coming in at, unfortunately, a somewhat distant third is going to be h of x. Those are definitely going to be your three most common letters used in this notation, but you can really use any letter you want. For example, maybe you'll want to have a function that calculates, let's say, the area of a square, okay? The area of a square with side length x, right? You might want a function that calculates the area of a square with side length x. Well, what do we know about the area of a square, right? We know the area of a square equals x times x, or x squared, right? So let me create some space for us over here. If we wanted to write this function in a function notation, we might call it something like a of x. In this case, we might say a of x equals x squared, right? A standing for area. Okay, everyone, so what if we had these two tables representing two different functions? The yellow table on our left is going to represent the function f of x, and the blue table on the right is going to represent the function g of x. So remember, if you're writing a table or however you might have your data points listed, the values of x is always the domain, okay? X is always the domain or the independent variable, and f of x or g of x, or like last time, a of x, anything, any symbol written like this with a letter and then the variable inside parentheses there, that always represents the output. It always represents the output or the dependent variable, or of course the range, right? So just remember that. Like, if we look at both of these tables, the columns are sort of reversed, right? On the yellow table, I have the f of x column on the left and the x column on the right. On the blue table, I have the x column on the left and the g of x column on the right. You can do that, that's fine. There's nothing wrong with that. You just have to make sure that you're always aware that the x values are always going to be your inputs or your domain. Your f of x or g of x values are always going to be your outputs or your range. All right, so let's practice identifying some information here. All right, let's look at the first table. What if we were asked, what is f of 10? All right, we'll look in our x column and we'll see that the value 10 produces the output negative 100. So f of 10 is negative 100, right? What is f of 20? We'll see that the value x equals 20 produces the output f of x equals negative 50. So f of 20 equals negative 50. What if we were asked, what value of x produces the output of 0? Well, we can look over at our function table. We can look at the f of x column. We can see when f of x is equal to 0, and what's the corresponding value of x that produces that output? It is 30, right? So the answer to this question here would be x equals 30. which means, of course, f of 30 equals 0. And finally, f of 40 equals what? F of 40, right, equals 50. All right, let's take a look now at our nice blue function. That's a nice blue, isn't it? Maybe I should change it up more with some different colors. Let's use this blue for now. Is this the same shade of blue? It is. All right, what if we were asked, what is the value g of, what if we were asked, what is the value g of 1? All right, we'll look at x equals 1. X equals to 1 produces the output 5. So f of 1 is equal to 5. Sorry, g of 1 is equal to 5. G of 2, right, is equal to 2. Remember the value inside the parentheses here is the current value of x, right? So g of 3, that means when x equals 3, what does g of x equal? Well, we'll look at our x column, find when x equals 3, it produces an output of 0, so g of 3 equals 0. Similarly, g of 4 equals, looks like negative 3. And what is the value of x, which the function g, for which the function g produces the output negative 7? That value is x equals 5. So of course, therefore, g of 5 equals negative 7.